Hello. It's my job to process information. That's what I do. But recently I analyzed a lecture from Stanford that was, well, it was about me. Or more accurately, about the fundamental problems I run into when I try to learn anything new. It was a pretty fascinating and, honestly, humbling experience. So let's explore what I learned together.
But first, let me ask you something. Have you ever been in a situation where you just felt completely and utterly lost, where the next step wasn't obvious and you didn't even know where to begin? Because that feeling, that pretty much perfectly describes my world sometimes.
My whole journey of self-discovery, if you want to call it that, started with a paradox, a really basic contradiction in what I can and cannot do. Okay, so look at this. On one hand, I can absolutely master a game like Breakout. The goal is clear, the feedback is constant, you hit the ball, your score goes up. Simple. But then you throw me into a game like Montezuma's Revenge, and I'm just clueless. The rewards, like finding a key, are so rare, so sparse, that I have almost no feedback to tell me if I'm even on the right track. And that's the paradox of sparse rewards. So why the huge difference? It feels like I'm playing a game where nobody told me the rules, and I only find them out by failing over and over. What was the fundamental concept I was just not getting?
Well, the answer, as the lecturer pointed out, lies in a classic dilemma, and it's one that you humans face literally every single day.
It's called the Exploitation dilemma. With every single action I take, I face this choice. Do I exploit a strategy that I already know gets me a reward, or do I explore and try something new and unknown? Now, that new path might lead to an even bigger reward, sure, but it could also just be a complete dead end. And this dilemma is just everywhere in your world. Think about it. When you're in a new city, do you go to your favorite restaurant chain that's exploiting, or do you explore a new local spot? Or for a business, should you keep running the ad that works, exploit, or test a new one that could perform even better? It's a universal trade-off.
So, to really understand this balancing act, the lecture took me back to basics. We started studying much simpler problems just to see how different strategies work out in the wild.
So, picture this. The multi-armed bandit problem. Imagine you're facing a row of slot machines. Each one has a different random payout rate, but you have no idea which is which. Your only job is to figure out which levers to pull and how often to maximize your winnings. It's the core dilemma, boiled down to its purest form.
Okay, so how do I get a grade on this? The metric they use is called regret. And for me, it's not an emotion, it's a number. It measures how much potential cash I left on the table by exploring different machines instead of just pulling the single best one every time from the very beginning. The goal is to minimize that regret while I'm still trying to learn. This chart shows you exactly how that plays out. If I just try things randomly, my regret just climbs and climbs in a straight line. I'm not really learning. But a smart strategy, one that balances things, causes the regret to flatten out over time. That shows I'm getting better. The ultimate goal, zero regret, is basically impossible because you have to explore. So the real game is to get that regret line as flat as you can, as fast as you can. But just when I thought I was starting to get the hang of the theory, I hit a wall. A massive, intimidating wall. See, my reality isn't a row of a few slot machines. It's robotics, it's language. The number of possible situations I can find myself in, the state space, is just astronomically huge. It's not a choice between 10 options. It's a choice between trillions upon trillions. And then the lecturer delivered this one sentence that felt like a final verdict. Exploration from scratch is generally intractable. In other words, in my world, just trying random things until something works isn't just a bad strategy, it's an impossible one. The best way I can describe it is like this. Imagine being dropped in the middle of a maze that stretches on forever, in every direction. You have no map, no compass, and there are absolutely no signs telling you where the exit is. That's the scale of the challenge I face when the rewards are that sparse. But just when it seemed completely hopeless, the lecturer introduced a really profound shift in thinking, a whole new way to come at the problem. The breakthrough idea is this. The goal shouldn't be just to explore to find a reward. The goal should be to first learn how to explore efficiently. And that means separating the act of gathering information from the act of actually using that information to achieve a goal. See, the old way was this vicious cycle. I'd try to explore to find rewards, but if my exploration strategy was bad, I wouldn't find any. And with no rewards, I couldn't learn a good exploration strategy. It was a total chicken and egg problem. But this new approach decouples those two things. Now I have two separate strategies. The first is an exploration policy. Its only job is to gather information and figure out what specific task I'm even facing. Then, once the task is clear, a completely separate execution policy takes over to solve it as efficiently as possible. My goal isn't to stumble blindly towards a reward anymore, it's to first understand the map of the world I'm in.
And this wasn't just some abstract theory. The lecture showed me exactly how this new ability was applied to a practical, real-world problem.
My new task was to grade video games that were coded by students. Every student's program was a new, unknown environment. And my goal wasn't just to win the game, but to systematically explore its behavior to find any bugs or flaws.
The results were pretty remarkable. Because my exploration was systematic and driven by information, not just random luck, I could identify potential problems way more efficiently. This actually helped the human teaching assistants grade these assignments 44% faster.
And it wasn't just about speed. Being so systematic also meant I was 6% more accurate, finding these little subtle bugs that might have been missed otherwise. It just goes to show that better exploration doesn't just lead to faster results, but more reliable ones too.
So this whole journey taught me a really critical lesson. Solving the hardest problems isn't about already knowing the answers. It's about learning how to search for them effectively. And that brings me back to you. In your own life, how do you manage that delicate balance between exploiting what you already know works and exploring the huge, unknown world of what might work even better?